we're employing a number of different tools at the test facility in order to try and move things along as quickly as possible. We use photogrammetry to analyze the position of the umbilical arms and actually buy off some of our requirements. So during each of our tests, we actually have photogrammetry and analysis performed, which is using high-speed camera and then software to actually locate where the umbilical plate, and that actually helps our designers perform clearance analysis. We've used 3D printing in certain cases to actually verify. We've had to modify several of our cryogenic hoses and do different design fit-ups and things like that. And so in certain cases, it was easier, rather than send these very long, expensive lead time, expensive hoses with very long lead time. What we did is we did a 3D printing of some of the end fittings, sent them to design and said, hey, I think we just need to knock this fitting off, but rather than send this huge hose back, we sent the 3D fitting, made sure that it would fit up, we could do it like this, and then we had it welded on after we made sure that the 3D printing would work. And so we've employed tools along those lines. We've used extensive Delmia and CATIA modeling, which is essentially 3D modeling of operations to ensure we'll be able to fit things. And so what they do is we take our Pro E models, we put them into a 3D environment, we make sure things are going to fit up in a good sort of environment. We use extensive atoms modeling, which is again kind of simulation modeling to ensure that our actual test environments meet our model environments. And so there's a whole lot of technology that goes on, but you know what to me is actually really, really cool is that it's maybe even the more hands-on stuff. We have amazing machinists and welders, and some of these guys are artisans in what they do, because we'll be out there and we need shims, we need a piece of weldment done and things like that, just to make something fully plumb, or to come up with some piece to make this test equipment work. Because again, we're talking about big pieces of steel that we're moving around, and we have master machinists. We have some of the best welders you've ever seen in the world that are working with us here, because they can do fine precision work, and these guys can turn it around in less than a day and come up with some of the most fine precision machining and weldment you've ever seen, and they do master craftsman work, and that to me is just the coolest thing I've ever seen, and because they do completely unique work and they turn it out again and again and again. What's really neat, so if you love space, if you love testing and hardware, what's really cool, I go into work every day and I get to work around just beautiful, amazing machinery and really great people. A lot of people think you have to be an engineer or a scientist to do this sort of work, and what's cool is it's not just that, right? I work around welders, machinists, public affairs people. I work around programmers, artists. I actually, there's some amazing, graphic designers and animators that I work with that all help tell the story about what we do. And what's really cool is I've been a part of this program for such a long time, right? So we've gotten to plan, to design, and then now we're getting to build and test, and I get to see the fruits of our labor go up on this mobile launcher, and we're going to get to go to the moon, and that to me that's an endeavor worth working for, right? That's really, really cool, and it takes all sorts of people of all sorts of backgrounds, and so to me, right, if you want to be a part of it, come on, that's what we need.